Good evening, everyone. A very warm welcome to all of you on behalf of Space Tutor KIYE Foundation. This is Yashaswini, one of the student coordinators from Kalam Institute of Youth Excellence, and I'm delighted to welcome you all to the fifth lecture of S-Talks, Space, Aerospace, and Futuristic Technologies. To everyone joining us live on YouTube from different parts of the country, very warm welcome. We are so glad to have you with us this evening. Before we begin, let's make this session interactive right from the start. If you're joining us live on YouTube, drop a quick hello in the chat and let us know where you're joining from. We are allowed to see participants connecting from across India. That's the beauty of S-Talks. Students, educators, professionals, and institutions from all over the country coming together with one shared goal: to learn, explore, and grow. And that truly reminds us that curiosity for space and technology knows no boundaries. What makes this journey even more special is that it continues every single Saturday. Yes, every Saturday we come together to learn something new, connect with experts, and grow stronger as a community. Because the more we connect, the more we stay consistent. And consistency creates impact. S-Talks is not just a lecture series, it is a platform, a community, and a mission inspired by the vision of APJ Abdul Kalam sir, his deep commitment to national building. S-Talks aims to ignite curiosity, inspire innovation, and shape the future of young minds. And our theme remains the same. Space is the next destination. Let's explore it together. Before we move ahead, let's quickly understand what S-Talks is all about. The S in S-Talks stands for Space, Aerospace, and Futuristic Technologies. This initiative is dedicated to inspiring young minds towards the exciting world of space, science, innovation, and emerging technologies. S-Talks is a year-long online lecture series featuring 52 lectures, 52 speakers, 52 topics, and 52 hours of knowledge and inspiration. This is not just a lecture series. It is a movement to build the next generation of scientists, engineers, innovators, and future leaders. And through S-Talks, participants get the opportunity to learn directly from the top scientists and industry experts, explore career opportunities in space and defense sectors, and earn certifications through active participation. Sounds exciting, doesn't it? And we are just getting started. Now, before we move further, let's take a quick look at a short audio-visual presentation that highlights the vision achievements of KIYE. Over the years, KIYE has successfully conducted some of the largest and most impactful science and defense events. Another landmark initiative is the Kalam Space Convention conducted on the occasion of National Science Day, hosted at prestigious venues like Shiva. S-Talks is designed as a continuous platform for learning and interaction. Here, scientists, industry leaders, and experts come together regularly to share their knowledge and experience in space, aerospace, defense, and emerging technologies, unlike one-time events. S-Talks ensures that learning becomes consistent. It creates an environment where students can stay connected, stay inspired, and stay informed week after week. This initiative reflects the evolving vision of KIYE. Today, KIYE stands as a platform where students don't just dream, they gain the direction. They don't just learn, they connect, they just aspire, they take action. In a country that is rapidly advancing in space and defense, platforms like KIYE play a crucial role in shaping the next generation. Because the next scientist, the next innovator, and the next leader is sitting right among us today. Now, before we move further, let's take a quick look at a short audio-visual presentation that highlights the vision and achievements of KIYE. That was a glimpse of KIYE, a platform where young minds are guided, inspired, and given the right direction to dream bigger. And now, to share that KIYE truly means from a student perspective, I invite one of our dedicated student coordinators, Shruti, to share her experience with KIYE. Shruti, over to you.
Good evening, respected dignitaries, mentors, and everyone present. Thank you so much for the opportunity, Yashashwini. I'm honored to share my journey. I'll keep this simple and brief. When I started my first year as a chemical engineering student, I was interested in space and defense, but I already started doubting whether I was capable of pursuing it or not. Around KIYE. Before attending my first event conducted by KIYE, I had a call with the founder, Naresh Indian sir. It was a deep conversation. Even at the first call, I learned very important, a sense of access. It made me feel that maybe I could step into a space I had always kept at a distance. I attended the National Science event in 2023, and that was my first real exposure. For the first time, I was in an environment with scientists and industry leaders I had only seen from afar. I gathered the courage to speak to Somnath sir, my ever inspiration personification that day. And that small interaction changed something internally. The thought that this is not for me started to break. After that, KIYE went beyond motivation. I visited the BrahMos facility, interacted with scientists there, and saw things firsthand. Later, during large-scale initiatives like Vigyan Vaibhav, I moved from being an attendee to taking responsibilities. working alongside professionals and contributing to coordinate few thousands of students. And recently, I had the privilege of hosting Kalam Space Convention 2025 with Shubhanshu Shukla sir as the chief guest. Looking back, the change is very clear, not because something extraordinary happened overnight, but because I was consistently placed in environments that expected more from me. So, if I had to summarize my journey, KIYE helped me stop holding myself back and started stepping forward. Thank you. Jai Hind.
Thank you, Shruti, for sharing your experience so beautifully. Your words truly reflect the spirit, passion, and purpose of KIYE. Now let's bring a little more energy before we move to our speaker. Everyone joining us live, if you're ready for today's session, drop a quick ready in the chat. And throughout the session, feel free to share your thoughts and questions in the YouTube live chat. We will be taking selected questions during the Q&A session at the end. So stay active, stay curious, and stay engaged. And now comes the most awaited moment of today's session. It is my deep honor to introduce our esteemed speaker, Mr. Pradeep Laxman Savalkar, sir. Sir is a distinguished aerospace and defense professional, currently serving as senior lead engineer at Collins Aerospace with his strong expertise in aerospace and defense technologies. He has contributed to practical engineering solutions in high impact domains and brings with him valuable real world industry and research experience. Beyond his professional achievement, he is also passionate about guiding and inspiring young minds through knowledge sharing and mentorship. We are truly honored to have you with us today, sir. And now, without further delay, sir, the virtual stage is yours.
Hello.
Myself, Yashaswini.
Hello, everyone. Yeah, can you able to hear me?
Yes, sir.
Yeah, I am sharing my screen. So let me know once it is visible.
Okay, sir.
It is visible.
Yes, sir.
Can anyone confirm the first screen is visible? KIYE Foundation. Hello.
Sir.
Can you confirm anyone? My PPT is visible.
No, sir. PPT is not visible.
Okay, give me one second.
Select the screen, sir.
Yeah. Yeah. Now it is visible, PPT.
No, sir.
No. Yeah, now it is visible, PPT. Can you confirm anyone?
Sir, you stopped sharing your screen.
Yeah. 1 second. It's not visible. Huh?
It's visible, sir, now.
PPT is visible?
Yes, sir.
Yeah. Sorry for the delay. Okay. Can anyone confirm the first PPT is visible? Huh?
It is visible, sir.
Yeah, sure. Thank you. Yeah. Good evening, everyone. Hello. Can you able to hear me?
Yes, sir. Good evening, sir.
Yeah. So I feel proud and grateful to the Kalam Institute of Youth Excellence Foundation for giving me this wonderful opportunity to interact the large number of engineering students. And it is my privilege to share my knowledge and experience to the young minds. Okay, let's start my special talk on how the engineering stream can tackle the real world aerospace challenges and role of the industry. Okay, so can you able to anyone can identify what is my topic? Can you tell? Hello.
How engineering stream can tackle real-world aerospace challenges?
Yeah, aerospace challenges and role of the industry. Here I mentioned the term engineering, right?
Yes, sir.
Yeah, you all are engineers, right?
Yes, sir.
Okay, let's talk about the engineering. Okay, what is the engineering? First, you have to understand, right? Engineers are the people who uses the science, physics, mathematics, and real world problems and practical skills to solve the real world problems and create the useful systems, machines, and technologies, right? This is what engineers will do, right? Agree?
Yes, sir. Agree.
Yeah. So we have the multiple engineers here stream, and we need to check about how all the engineers will help in our aerospace and defense field, and what are the challenges, real world challenges, and what is the contributions of public, private industries, and how those problems and challenges they will resolve. Just we need to understand. I think already my introduction is over. Just I wanted to tell you I completed my engineering in computer science and Master of Technology in Computer Network Engineering. And later I joined DRDO and currently I'm working in Collins Aerospace as a senior lead engineering. And I'm the Aeronautical Society of India student wing coordinator as well. And I started the India's first volunteer self-funded aerospace and defense awareness campaign for the government schools under the theme of young minds with the spirit of science, service, and Swadeshi excellency. Okay, this is my campaigning poster photo for Aeronautical Society of India, and till now I covered many number of schools. Okay, so this is can I able to see my slides how the engineering stream tackle the aerospace engineers. We have the multiple engineering streams like aerospace engineering. Okay, and they deal with the design and integration system, overall design and integration system, the aerospace engineering. And mechanical engineering, they deal with the structurals and mechanisms. And aeronautical engineering, flight performance. Thermal engineering, heat and thermal management. Electrical and electronics engineering, power and avionics system. Electronics and communication engineering, basically they deal with the communication and sensing system. And computer science engineering, basically the software and intelligence. Okay, and environmental engineering. So all the engineering work together and we achieve the safety of the product, performance of the product, reliability, sustainability, and cost effective and global impact. This is how the entire the engineering stream work together, and we solve the real world problems in aerospace and defense. That means we, whatever the product we are developing, like aerospace or defense related to satellites, aircrafts, unmanned aerial vehicles, we need all the branches. Okay, in one isolation branch only it won't work. Like only you are working with aerospace engineering. No, we need all the branches together to build a one complete product. Correct. So first I will go through it one by one. What are the engineering's stream tackle the aerospace challenges? Like mechanical engineering. Mechanical engineering basically they involved in the structures, aerodynamics, and propulsion system. Okay, and electrical and electronics engineering involved in the avionics, sensors, communication system. Computer science and software engineering involved in the flight control software, artificial intelligence, embedded system. Material engineering involved in the composite and heat resistant and alloys. And system engineering, integration, safety, and certification. This is the real world problems like fuel efficiency, safety, reliability, require all these streams working together, not in isolation. You have to understand all the branches we need to develop any one product. Okay. So next I will go through it. Mechanical engineering. This is the core physics of the system. Okay. Mechanical system engineering involved in the what they handle. Okay. Everyone aware about the aerodynamics? Hello?
Yes, sir.
Yeah. You know, if any aircraft or any object is flying in the air, 4 forces acts on the aircraft, right? Can you define any one of them? What are those 4 forces? Hello. Okay, just I will explain you. Aerodynamics, what are the 4 forces acts on the aircraft? The downward force, you know, the downward force is the lift or gravity or weight. Due to the weight of the aircraft, it is a downward force. We call it, that is the gravity. Upward force is the lift. Okay, to generate the lifting through the wing, we need to generate the lift. And forward force is the thrust, backward force is the drag. And these are the aerodynamics. To study how the objects fly in the air and what are the 4 forces acts on the object or aircraft. This is we call the aerodynamics. Okay, and flow behavior. Okay, so this is the mechanical engineer involved in the aerodynamics, structural design. You know, in aircrafts we have the lakhs of components. Okay, and I will tell you about what are the 5 main components of the aircraft. First, the structure of the design. And to design the structure of the aircrafts, I will explain you what are the 5 main components of the aircraft. First main components of the aircraft is the fuselage. You know, the long hollow tube which holds the passenger and cargo is called the fuselage. And wing. In fixed wing, we have the larger wing, and the forward, backward is the smaller wing. So this is the wing to generate the lift of the aircraft, and airframe. And this is the structure design and propulsion system like engine, turbines, thermal system like cooling, heat transfer. So this is what the mechanical engineer handle the aerodynamic, structural design, propulsion system, and thermal system. And what they will face the challenges, in the real challenges they solve in the mechanical engineers. First one is the fuel efficiency, reducing the drag to improve the fuel efficiency. You know what is the drag? The backward force is called the drag. Due to the unaerodynamic shape, the drag will be more. So it is very difficult to move any object in the air. So it will be backward force. It is a drag. So if you reducing the drag to improve the fuel efficiency. Okay, that is the one of the major challenges in the aerospace and defense field. Okay, so first you have to understand how the fuel efficiency we need to improve. How we need to improve? If you are reducing the drag, then only fuel efficiency it will be. That is the major challenges right now in the mechanical engineering point of view. And designing the lightweight but strong structure. I told, right, the aero structure like fuselage, wing, empennage, and landing gear. These all are the aerostructures. How we need to lightweight. Okay, if we have the heavy weight, we need the more fuel. So it is a lightweight, strong, and high strength, heat resistant. So this is the material we need to use and to develop the aerostructures, and handling the extreme temperature like re-entry and engines. And to resolve these challenges and problems, we need the tools and methods like CFD tool, okay, in mechanical engineering, computational fluid dynamics, and FEA and finite element analysis, wind tunnel testing, okay. And these are the tools and methods used in the mechanical engineering. And industry rules like to develop this aerostructures, propulsion system in private companies like the Boeing, Airbus, Collins Aerospace, Tata Advanced System. Many the private companies are there to build the mechanical engineering for the aircraft design and performance and optimization. Without mechanical engineering, nothing flies physically. Okay. Yeah. Any doubt in the slides? Or you will ask the end of the session?
End of the session, sir.
Okay. This is just you understand the mechanical engineering is how it is the important to fly the object, to fly the aircraft or satellites or spacecraft. We need the structure. So this is what mechanical engineering will do. Here major challenge is the fuel efficiency and lightweight design of the structures. This is the two major challenges in the mechanical engineering. Okay. And next, the electrical and electronics engineering. They basically deal with the avionics system and control system. You know what is the avionics system? Avionics means aviation plus electronics. Okay. If any electronics and aviation system, we call the avionics system, like display system, navigation system, and monitoring, the communication systems. These all are the related to the electrical and electronics engineering. Basically, they deal with the flight control system, sensors, radars, communication system, and fly-by-wire technology. You know what is the fly-by-wire technology? This is the latest technology. Like completely computer is handling the primary and secondary control surfaces of the aircraft. Okay, you know the aircraft movement. Like there are the three aircraft movements of the aircraft, or three aircraft control surfaces. One is the ailerons. Okay, ailerons means roll of the aircraft, and elevator, the pitch of the aircraft, the up and down, and rudder, like towards the right and left. So this is the primary and secondary control surfaces of the aircraft to control the movement of the aircraft. So this is the we need the electrical and electronics engineering. This is the fly-by-wire technology. Before manually it is controlling, manually we are handling these primary control surfaces. Now completely computer it is handling. That is we call the fly-by-wire technology. Okay. And here we example like a stability and control system to ensure the safe flight even in the turbulence. And this is what I told already, electrical and electronics engineering. These are the aircraft's brain and nervous system of the aircraft. What they will handle: avionics system, sensors. In the aircraft, we have the pressure sensor, temperature sensor, radar sensor, like different kinds of sensors are there. This is what electrical and electronics engineers deal with, those sensors. And power systems like generation, distribution, communication systems like air-to-air communication, and air-to-ground communication, air-to-air traffic controller, ATC communication system. We have the variant ultra-high frequency, high frequency. See, this is all the communication system we use. We call that is the radios. Communication system is a radios, vary and ultra-high frequency radios to communicate the air-to-air, air-to-ground, in-ground air traffic controller. And the real challenges, what they will face the real challenges? We need to send the communication system. Okay, so we need the reliable signal transmission. Okay, if you are transmitting a wrong signal or unreliable signal, it is a difficult to get the signals and to get the false information to the aircraft. So reliable signal transmission. This is the real challenges in the electrical and electronics engineering. Okay, and power efficiency and redundancy, because we are developing like a critical systems, and we are working with a critical safety critical system. So we need a redundancy system, like we need a multiple system. If one system is failure, another system acts like a simultaneously. For example, we have the 2 engine in some aircraft, 4 engines. One engine is failure, another engine can be work parallelly. If one flight control is fail, another flight control can work parallel. If one flight management system inside the cockpit display system is fail, another redundant display system will work. This is why we need the redundancy system. That is the real challenges now we are facing. We need to develop the redundant system, reliable signal transmission, and application like flight instrumentation, radar system, and satellite communication. And the industry involved in this technology like DRDO, Collins Aerospace, Thales, and the Tata Advanced System, Airbus, Boeing, to develop the advanced avionics system and mission system. Okay, avionics system is nothing but a cockpit. Cockpit, we have the flight control, communication system, the primary display, secondary display, navigation system. These all are the avionics system. In avionics systems are the brain and nervous system of the aircraft. And mission system. Mission systems are the here, okay, here or weapon delivery system, and eyes of the system. These are the mission system, like radars, secondary surveillance radars. These all are the mission system. The stream ensure the aircraft can sense and communicate properly. This is what the industry role to develop the such a flight computers, radar system, satellite communication system, and sensor avionics system. This is what electrical and electronics engineering can be involved. Next, the computer science and software engineering. Okay, we need to understand the computer science is the very important subject to build the software. Okay, the complex system integration and real-time computer. You know, to build the flight computer or flight management system, we need the flight software. Okay, that is we call once the aircraft can travel from the source to destination, we need the flight software. That we call the DO-178C standards. As per the DO-178C standards, we need the softwares. You know, these are the aerospace and defense standard. D178C or D178B is a certification consideration in airborne system and certification standard. That is the D178B or D178C. In these standards, we explained the. Give me 1 second.
Okay, sir.
So, you know, the DO-178C deal with the software. How first to build a software, first we need to plan. Okay, plan means what are the standards we need to involve, how to certify those software, and what is the software development life cycle. This we need to plan. And what is the software criticality level, like level A, level B, level C, level D. It's based on the catastrophic failure of the aircraft or hazardous failure of the aircraft, major, minor, or there is no failure. Based on these things, first we need to plan. Okay, this is everything. Planning is mentioned in the DO-178C standards or guidelines to develop the aerospace and defense standards. In the standards or in these guidelines, it is mentioned about the planning documents like PSAC, plan for software PSAC, planning documents, and software development plan, software verification plan, and software configuration management plan, software quality plan. See, these are all the planning documents we need to mention. Once planning is done, we need to develop our software product. We call that is the software development plan. In software development plan, first we need to take the requirements, high level requirements, low level requirements, then software architectural, then software coding. So we need to develop those software development. Once software development is over, then software verification. Like in software verification, we need to test those product. testing, analysis, reviews, audit. It will becomes in the testing phase, and finally it comes into the certification authority, final certification. What is certification? Once the product is ready, we need to certify from the certification authority. In the international level, we have the FAA, Federal Aviation Administration. In India, we have the DGCA, Directorate General of Civil Aviation. If any aerospace and defense product can be certified from the DGCA, and defense perspective, we have the DRDO's SEMILAC. Okay, SEMILAC is the certification authority to certify our entire software structures as per the D178B standards, like flight control system and radars. This is all the components of the aircrafts. This all the certified from the certification authority, FAA, DGCA, and SEMILAC. Okay, and what are the examples? Software controls aircraft system, ensure the safety critical application. We are developing this safety critical software. There are the 5 safety critical system, or 5 levels of the safety. One is the level A. Okay, level A means the catastrophic failure of the aircraft. For example, catastrophic failure of the aircraft is nothing but a landing gear. Okay, it is impossible to recover those failures, and it is either the aircraft loss. In this is the level A, catastrophic failure of the aircraft is a level A, and level B is the hazardous failure of the aircraft. So and major failure of the aircraft, minor failure of the aircraft. There is no failure of the aircraft. This is what in aircraft, aerospace and defense, we categorize the failure levels of the aircraft in the computer software perspective. And this the computer science is involvement in this field. I already explained about this, what they will handle: flight control software, embedded artificial intelligence, and machine learning. Nowadays, the latest stream in the software, AI and ML for the entire the flight control software, and simulation and modeling. And they will handle the safety critical software must follow the standard like D178B is the earlier, now is the latest D178C. It is the software standard. In hardware guidelines and hardware standard is the DO254. Okay. In environment standards, DO160. And the system and safety standards is the ARP 4754A or ARP 4761. These are the safety and system standards. See, we have the multiple standards. You need to understand what are those standards. Okay, don't go for the practical knowledge. That is the reason we are failing here. All the engineers, why we are failing? Because of they don't have the practical knowledge. One, they don't know about the standards. They don't know about how to develop the product. Okay, once you develop, first we need to plan, then build, then we have to test it, then maintain. This is what the entire life cycle will go. First, we need to understand how the real time it will be work. What are the standards? You should know about all the standards. Whatever I told, all the standards. Please, if you are interested in this field, aerospace and defense, please aware about the D178B, D178C, DO160, and ARP 4754A, ARP 4761. These are the standards you should know. Okay. And what are the challenges we are facing in computer science? Zero failure tolerance system. Okay, to build a software, it is impossible. We need a zero failure tolerance system. Even a 0.0001% failure in the software is not acceptable, because we are working in a real safety critical system. Okay, so that is what we need to maintain while we are build the software. We need to follow the mandatory D178B or D178B C guidelines or standards. Okay, and real-time processing system and cyber security in avionics system. Nowadays, cyber security is more to attack our avionics system like communication system, radars, display system, navigation system, monitoring. In this field, nowadays it's more how to avoid the cyber security. Such a system, such a software, you have to build it. That is what real challenges we are facing in the computer science system. And what are the application? Autopilot system, UAV navigation, fault detection system, and software decide how the aircraft behaves. Okay. And the aerospace engineering, what they will handle, like aerodynamics, I told, aerodynamics, propulsion and structural integration, flight mechanism and stability, and how to the aircraft stability. You know, the tail end of the aircraft is called the empennage. In empennage, we have the vertical stabilizer, horizontal stabilizer. In horizontal stabilizer is attaching to the elevator, and vertical stabilizer is attaching to the rudder. How the aircraft, the stability of the aircraft, how the aircraft is stable, and what are the flight mechanisms and guidance, navigation and control, GNC we call. This is what the aerospace engineering deal with the this system. And real challenges facing in the aerospace engineering: stability of the aircraft, orbit design for satellite, mission level optimization, and the aerospace engineer connect the physics to flight. And the chemical engineering. Everyone, you are in same slides, right? Chemical engineering.
Yes, sir.
Okay. See, chemical engineering also very important. You know, the chemical engineering challenges, I will tell you, the efficient and clean propulsion, like jet fuel chemistry, combustion optimization, rocket and liquid, solid, cryogenic. You know, the fuel. We need mandatory the aircraft fuel or satellite to launch the satellite in the space launch vehicle. We need the fuel. So how this is what chemical engineering will involve in the fuel chemistry, okay, and improving the fuel efficiency and reducing the emissions. Nowadays, due to this fuel, we need lots of emissions. How we need to reduce those emissions? This is also one of the major challenges in the chemical engineering. And material engineering. So to build any one of the product like aircraft, satellites, spacecrafts, we need the materials, okay, to build the aerostructure like fuselage, wing, empennage, landing gear, and engine. What are the materials we are using? This will come in the material science or metallurgical engineering. We have the multiple material engineering, like to build a aerostructure, fuselage, we need the aluminum alloys or titanium alloys and carbon fibers and heat resistant alloys. See, this is materials we need to use. Why we need to use this material? Because these all are the aluminum alloys, titanium, carbon fibers. These are the lightweight, strong and heat resistant materials. That is the reason we are using. And here major challenges is how we use such a materials, and we need to extreme temperature we can absorb and pressure. This is what the major challenges. What are the different materials we need to use? Okay, we need to. This will comes under the material engineering. And I told already, composite materials, high temperature alloys, and real challenges we are facing like lightweight. We need the lightweight and high strength, heat resistant, and long life cycle durability. Whatever the material we are using, we need the long life cycle durability. This is the real challenges we are facing in the materials. And application like the aircraft fuselage composite to develop the aircraft fuselage, like long hollow tube which holds the passenger and cargo, and turbine blades, use the blades, right? This is the application. And these materials determines how long and how safely system survive. This is what the material or metallurgical engineering can involve. And civil engineering also, it is important to we need the runway, airports, structural safety, and solution like the runway design and maintenance, and hangars and testing facilities, and for example, designing the runways for the heavy aircraft loads. This is the civil engineering involved in the aerospace and this field. We need the airports, runways, and structural safety. Okay. And industrial and production engineering, we need the challenges like cost, manufacturing efficiency. Okay. And we need the lean manufacturing, supply chain optimization, and example like efficient aircraft production lines. And this is the industrial and manufacturing engineering involved in the real challenges we are facing in the scaling from the prototype to mass production, maintaining the precision manufacturing and cost optimization, the application like aircraft assembly lines, lean manufacturing, Six Sigma quality, and design is useful if cannot be manufactured reliable. We need the manufacturing environment facilities. This is the manufacturing engineering will be involved, and the system engineering. Finally, it will come in the system engineering. Integration of all the subsystems, and we need to ensure all the components work together. Okay, then only we can develop one final product, one final aircraft, or one satellites, or one launch vehicle, one space station. This is what entire the subsystem work together, and all components work together. We have to build such a components. It will comes under the system engineering, and safety, reliability, and finally certification. And example, coordinating the avionics, propulsion, and structure into the one system. And this is the real challenges. Ensure the all subsystem work together, managing the complexity, certification and safety, compliance. When we work all the subsystem certification, it will be go for the certification. All the subsystem, it is difficult to get the certification authority from FAA, DGCA, or SEMILAC, because if any problem or any error or it won't give the certification authority. This is what one of the major challenges we face. Okay, and next, now we are using the emerging streams like future aerospace, AI, and data engineering, predicting the maintenance, autonomous system. To build an autonomous system, we need the artificial intelligence and data engineering, robotics, space rovers, UAV, and cyber security. I told protecting the avionics from the attacks. This is the latest streams we are using nowadays. Apart from this engineering stream, AI, robotics, and cyber security. And already I told the real world aerospace challenges solved. Fuel efficiency. In fuel efficiency, you see how many engineers are involved in fuel efficiency. Mechanical engineering, chemical engineering, and materials. And flight safety involved in the electrical engineering, computer science engineering, system engineering. Space mission involved in the aerospace engineering, computers engineering, and material engineering. Cost reduction involved in the industry and system engineering. See, this is the solving the key aerospace challenges: fuel efficiency and sustainability, safety and reliability, autonomous and artificial intelligence, and space exploration. And this is role of the industry already. Role of the industry in aerospace engineering. Industry is where theory becomes the reality. Okay, this is what the industry or public or a government organization work will come. Here practically they will work reality. Okay, and design and development, like companies like Collins Aerospace, Thales, Airbus, Boeing, Defense Research and Development Organization, DRDO, and they design the avionics system, aircraft system, and defense technology. And research and innovation, development of next generation technology like hypersonic system and electrical aircraft, collaboration with the academia, startups, and simulation, digital twins, and advanced testing. So, and how the industry brings it all together. I told, right, organization like Boeing, Airbus, DRDO, Collins, and they work together to build the integration system, testing the system like in ground level testing, flight testing, simulation, finally certification authority with DGCA, Federal Aviation Administration, and SEMILAC. Okay, and this is the final my slides where many engineering stream go wrong. Okay, this is you have to understand why we are facing these challenges, why we are making that wrong we are going. Because let's be direct, many graduation struggle because too much focus on the theory, not application. Okay, they always focus on theory. They don't know practical how it will be work. That is the reason we are struggling. So we don't know how it practically will work. So my sincere request to all the engineers, instead of theory, work the practical. Okay, lack of hands-on projects. Okay, work on the real-time projects. No exposure to the real aerospace standards. That is the very, very important. You should understand what are the aerospace and defense standards. Like I told, the software standard D178B, now latest D178C. The hardware standards or hardware guidelines DO254. And the system and safety guidelines or standards ARP 4754A, ARP 4761. and the environment guidelines or environment standard DO 160. Like, the environment standards is nothing but the vibration testing. If any such aircraft we need to develop, we need the vibration testing, high temperature testing, low temperature testing, wind tunnel testing, and rain testing. So this is it will comes under the environment testing. We need to follow the DO 160 standard. So you should aware about their standards and weak understanding of the system level thinking. So we have to understand what is the entire system, what is the software development life cycle of the system to develop the product, to build the product, and to test the product, and finally to how it will go the certification. Then only the entire product will come over the real time. Okay. So, and aerospace industry needs the problem solvers, not just a degree holders. So we need the problem solvers, not a degree holders. And what actually work practically path means work on real projects like unmanned aerial vehicle, radar controller aircraft, simulation system, and lean the certification mindset. You should understand how the certification authority will work and safety point of view and documentation, and build the cross-domain expertise. Not only one expertise, like if you are mechanical engineering, please understand what the aerospace engineering will do, what the computer science engineering will do, what the electronics and electrical engineering will do, what material engineering will do. You should need the cross-domain knowledge. Then only we can build such a beautiful product without a zero failure of the aircraft. Okay, and understand the industry standards and tools. I told about what are the industry, aerospace and defense standards, and what are the tools we need to useful for each and every engineering stream, and participate in the organization like the Aeronautical Society of India, Institute of Electronics and Telecommunication Engineer, Institute of Engineers. These are the society. It's my humble request to everyone. If you attend such a organization who work really in this field to give the practical knowledge and to conduct such a event and seminar and international conference and seminar by bringing the scientists like Aeronautical Society of India, you get the membership there. Okay, so this is my last slides. It's an honor. I met Subhanshu Shukla in the second National Space Day in Bharatam Mandapam, and he wished my campaigning for this aerospace and defense awareness campaign for our government school. And he's my guru, and I think our Kalam Foundation mentor, Dr. G. Satish Reddy, is my guru and my beyond force, and the Kalam Institute of Youth Excellency mentor, and is our God. So, and it's an honor to given my handmade aircraft to Bharat Ratna Award Professor C.N.R. Rao. Is also my guru. And this is, I am trying my simulation. Can you able to see? This is the cockpit. You see the multiple, entire the avionics system and mission systems are here. And primary display system, navigation system, monitoring, and how we have the redundant system. This is what entire the cockpit looks like. And if you have any question in further, please take my personal mobile number, my website, and please mail me if you have any doubts, questions. Okay, and it's very, very important. Always our mentor and our guru, Dr. APJ Abdul Kalam, he said always, okay, student needs to be dream. Which dream? Not your sleeping daily night, that not that dream. Dream. Dream transform into your thoughts, and thoughts result in action. This is what Dr. APJ Abdul Kalam always believe the students. Okay, students is our future. They will, our future. Always student, Kalam believe with student only. So you all are our future creator. Okay, so my sincere request to everyone, please, whatever I told, please go through the standards, go through the real-time project, and go through the entire software development life cycle in the aerospace and defense field. So this is what I given a very, sorry, I'm busy with my personal work. Didn't I, like, I did immediately, and I joined without any makeup or anything. So it's not my face is important. Always keep your knowledge, and knowledge. Okay. Always gain the knowledge. My humble request to everyone, knowledge is a powerful tool in the world. If you have the knowledge, you can, any real world problem, you can face it. Please gain the knowledge, multiple cross-domain expertise. Okay. So this is my humble request. Please gain the knowledge. And finally, I need to thanks to, he is my mentor also, and my well-wisher and my friend, Kalam Institute of Youth Excellency, Shri Naresh Indian sir, because he given this wonderful opportunity to inspire the young minds. I thanks to the Naresh Indian sir and all the organizers. Excellent, you are organizing. What a beautiful events, and what a beautifully you are organizing, and you are giving I heard all entire the student community is working this work. So I'm very happy about you. If you need any help, please interact with Naresh Indian sir, and please interact with me. Whatever the possibility way, I am here. Okay. Don't go. This is my first and last. Okay. This is not my first, and this is not my last. Okay.
Thank you so much, sir.
Yeah, and namaste, and thank you. Yeah, please, if you have any question, let me know.
Thank you so much, sir, for that insightful and inspiring session. Your words gave us a deeper understanding of how different engineering streams come together to solve real-world aerospace. Now I invite Mokshita to ask a question. Mokshita, can you unmute?
Hello, sir.
Yeah. Let's say you can talk about whatever I asked, in my contents. Let's, if you have any question, let me know. I can give the more clarity.
Okay, sir. Hello, sir.
Yeah, hello.
This is Mokshita from. Good evening, sir. This is Mokshita from SPR High School.
Mm-hmm.
Sir, what are the two main branches of aerospace engineering, sir?
Branches?
Yes, sir.
In aerospace engineering.
So
what kind of branches you are asking? Okay, like engineering you are asking?
Excuse me, sir. Sorry to interrupt. Can you stop sharing the screen?
Yeah, sure. 1 second. Yeah. Yeah, please go through. No, branches means you are asking the engineering branches?
Yes, sir.
Yeah, already I told about you, like you enter in the aerospace engineering, we need all the branches, okay? In aerospace engineering, computer science engineering, electronics engineering, mechanical engineering, electrical engineering, material engineering, artificial intelligence and machine learning. We need all the branches to work in the aerospace domain. And basically, I suggest if you take any branch is okay. If you take any computer science or electronics or aerospace engineering, it will be better to deal with the entire aerostructure of the components or spacecraft of the aircraft. So all the branches will equivalent preference. Not I told right, not in one branch. All branches work together to build satellites, to build one launch vehicle, to build one aircraft. It's not about only isolation branch. Okay, there is no isolation branch. All branches is equivalent important. Okay.
Okay, sir. Thank you.
Yeah, thank you.
So with your permission, next question. Rockets today launch and then land themselves back on ships at sea. What possesses the bigger engineering challenge now, reaching the space or returning safely?
Yeah, no, both are the equivalent important, because to launch the rocket from the space launch vehicle, okay, first we have to build such a space launch vehicle, whether it will be on PSLV or GSLV or any satellite launch vehicle. We have to build such a launch vehicle. And what is the criticality level here? First, we need to plan. I told right, before to develop any product, first we need to plan. Then we need to develop. Once it is developed, then test in real-time testing. This is how the entire software life cycle will work. Both are the equivalence important. Sending the rocket, sending the satellites from the satellite launch vehicle, it is also very critical, because if any minor failures, it will be blast or it will be, it won't go the above. So both are the equivalent important. Sending and returning the back. So we call that is a reusable rocket. You know the SpaceX?
Yes, sir.
Okay, yeah, SpaceX is working for the reusable rocket. In India also, in ISRO, it is started already. Yes.
Yes, sir. Now with further questions. How will AI change aerospace engineering in the next 10 years?
Yeah, I told already. Now is the latest trends or latest engineering trends in artificial intelligence, machine learning, data science, robotics, and cyber security. They need to improve, or particularly in the avionics system, like in the flight control system, to build a flight control system, flight computer software and embedded software or autonomous software. Basically, we nowadays all the systems are autonomous. So that is helping in the AI. In another 10 year or another 20 year, you see the most of the system is like an autonomous system. Without we are reducing the pilot workload, automatically entire the software is take caring due to the AI. So it is coming slowly. It is started in all the industry, and in another you said 10 to 20 years, it is coming in another 10 years. Coming in the certification authority, those product already it is started. It is in planning phase already. Now it is in planning phase in AI. In another 10 years, it is in certification authority. They once certified, then it is completely autonomous system. Yes.
Sir, with your permission, can I take more questions?
Yeah, please.
What skills do industries like Collins Aerospace, DRDO, Boeing, and Airbus expect from fresh graduates?
Yeah, I told, right? See, I told graduation, taking just a degree is not an important. Okay. First, you have to understand. Degree everyone will take. What I told, along with this degree, you need the practical knowledge. You should understand the aerospace and defense and industry standards. First, you have to understand what are the standards. If you have the time, take the trainings from the standard D178B, hardware standards, software standards, system and safety standards. Take the training 15 days, online training, or check in the Googles and YouTube videos in IITs. They will give the trainings. So take these trainings during your graduation time, and we are expecting this one only. If you have such a knowledge, immediately your selection will go very smoothly. And understand the real-time scenarios. Work with the real-time component, real-time aircraft like unmanned aerial vehicles. So real-time project you have to work. And what is the latest trends or latest technology like AI, machine learning, data science, robotics, cyber security? This technology you can focus, or at least you should have the minimum knowledge. If you honor that minimum knowledge and industry standards and software development life cycle activities, that if you know along with your degree, you automatically will select in the Collins Aerospace, Airbus, Boeing, Thales, Tata Advanced System, Dhruva, Ballistics, and DRDO, ISRO, HL, NL, BML. Many organizations, many companies are there. Definitely, it will be helpful. Okay?
Okay, sir. Thank you. Sir, could you please brief us about the existing and upcoming opportunities in field of UAVs?
Unmanned aerial vehicle. Nowadays, the entire war system is changed. Before, once upon a time, we are manned war. Okay, manned means what? There is no man. Okay, with man means with pilot we are fighting each other. Now they changed it to unmanned aerial vehicle. We are using the robotics. Robots we are using. We are using the drones, particularly UAV. It is improved like the drones. We are making the war between the drones only. There is no man is involved. No manned aircraft is involved. Nowadays, they involved in the drones, UAVs. So this is what they involved in upcoming days or upcoming years. In this, they are all the defense organization. They are focusing on the UAVs. So if you are interested in this field, please focus on the UAVs and drones. And take the certification from drones from the DGCA. Yeah.
Okay, sir.
Yeah.
And one last question.
Yeah, please,
If a Mars mission fails, is it the rocket engineer's fault for not getting there or the life support engineer's fault for not keeping crew alive?
Can you repeat?
If a Mars mission fails, is it the rocket engineer's fault for not getting there or the life support engineer's fault for not keeping the crew
See,
alive?
I will tell you the generic. If any, you can take either the Mars mission is fail or any aircraft crash. These all are the safety critical system. Okay, they all are the safety critical system, and it's not about the fault in one system. It is a multidisciplinary fault. Okay, you said maybe maintenance issue or components issue, or they not checked properly components and the fuel problems, or any. It will become in the investigation after the failures or after the crash. We need the investigation report. Whatever I heard, 90% of the failure, it is a multidisciplinary failure, not in one failure. I can't tell about only one failure. It is a multi failures. Yeah.
Thank you, sir, for patiently answering the questions and encouraging young minds with such clarity and warmth. And thank you for all our participants for your enthusiastic and active participation. And also, sir, on behalf of KIYE, we would like to extend our heartfelt congratulations to you, sir, on your upcoming wedding and for starting new chapter in your life. Wishing you a beautiful new journey filled with happiness and success.
Thank you very much. And you are excellent, guys. Excellent. You are coordinating, arranging, asking the multiple question. Excellent. This team is a wonderful. I believe this team definitely. I can hope multiple scientists or multiple engineers. So you can work in the aerospace and defense field, especially in the DRDO, ISRO, HL, NL, and Airbus, Boeing, Collins, and Thales. If you need any help, please contact me. Okay.
Thank you so much, sir. As we come to the close of this wonderful session, I now invite Ms. Hasini to deliver the vote of thanks. Hasini, over to you.
Respected dignitaries, esteemed speaker, and dear participants, very good evening, everyone. On behalf of KIYE Foundation, I am grateful to propose the vote of thanks for today's session. I sincerely thank Mr. Pradeep Laxman Savalkar, sir, for this insightful session. Sir, your thoughts on aerospace challenges really made us think beyond the limits. And I would like to thank the KIYE Foundation team for organizing such a beautiful event and the participants who have been involved actively. And my special thanks to the technical team. Everything went smoothly. With this, we come to the end of the today's session. It was truly a valuable session for all of us. And don't forget to subscribe our YouTube channel, KIYE Foundation, join our WhatsApp channel, KIYE Foundation, and follow our Instagram channel, KIYE Foundation, for future updates. We are going to conduct online lectures on YouTube channel every Saturday, 6 p.m. to 7 p.m. Space holds endless possibilities. Thank you for giving this opportunity. Jai Hind.
Thank you, Hasini, for those warm and thoughtful words. We will be truly delighted to have many more such sessions with you in the future, sir. And to everyone who joined us today, let us stay connected, stay curious, and keep learning. Because truly, space is the next destination. Let's explore it together. Thank you, everyone, for joining us. Have a wonderful evening. Jai Hind.